Hello, everyone.
Hey.
Can you see my screen?
Yes.
Okay. Let's wait for 2 minutes for folks to join. Heads up, there's a spec PR just merged, which replaced all the labels to attributes. So if you search for labels in the entire spec repo, I think you can only find some places where people mention GitHub label, how you tag the issues. But for anything like the dimension on metrics, we call that attributes across the board. And there's another PR talking about for traces and metrics, leave the attributes as is, but for logs, people want to allow arbitrary type, like they want to support whatever type. Unlike the trace and the metrics attributes where we only support primitive and array of primitive types. Okay, we can start. So first thing, just heads up. So I updated the project board. Originally, we were trying to see if we can target a metrics SDK experimental release by end of June, and we couldn't meet it. So I said the new date has end of July, which according to the current progress, like if a PR is blocked for a month, then I think it's very aggressive. So so just heads up. And looks like we'll need some help here. So I try to break down the big items here. I think the view part, given I already started and it has been stuck, I'm willing to work harder and see if we can drive to any conclusion here. I'll talk about the details later. And for aggregator, I think I probably don't have enough energy. I'll need some help. So I wonder if like folks here, you can help to take some part so we can work in parallel. But understand everyone is busy, so if you're busy on something else, don't feel obliged. I can reach out to the other like spec folks. I remember like there are folks from the JavaScript, like Dynatrace, that might be able to help.
So really, what do you need help with regarding aggregators?
This is the spec work. So I expect like my goal is we have the skeleton of the spec so we can have people working on individual sections. So for example, meanwhile, I'm struggling with the view part. I'll try to address the concerns and consolidate different ideas. But meanwhile, I think aggregator can start without having to wait for the view PR.
All right.
I'm happy to help there, by the way.
So so Josh, thanks. It seems you have a very deep understanding on histogram and exemplar. So I wonder if I can put you on.
Yeah, yeah, and I think there's a high correlation there. Like I wanted to, well, anyway, I've been looking at how Prometheus does exemplars, and we have lots to talk about, but I'm more than happy to write down all my findings. And I was already working on an exemplar PR that has been sitting in my to-do list for a long time for the SDK. So I'm more than happy to take that and push it.
Yeah, and for the built-in aggregator, I wonder if someone else can take a stab.
I'm definitely not a great expert on this, but I can help at least reviewing the aggregator stuff.
Yeah, yeah. I think this part is challenging. We can probably talk about that later. I have some topic here, so talk about the aggregators. I wonder like if anyone else can give some help here.
I could try, but I don't know how much help I could be. I just base it on my implementation, current implementation.
Okay, so Victor, let me just put your name here, and you can send a PR and see where that goes. And if you need help, we can come back and see if someone else can work together with you. By the way, Victor, like probably you change your microphone or something, like your voice changed a lot. So it's very hard for me to connect your new voice with you. Just want to confirm it's Victor.
Okay.
You're speaking.
Is that better?
Oh yeah. It's strange. Okay, so for the exporter, currently I think about let's say concern. That part seems to me like quite straightforward. I think the exporter data model will follow the matrix data model, so basically the OTLP model, and the built-in exporters we should just have 4 of them. So that part should be straightforward, unless someone see I'm over optimistic.
Where are we accounting for the pipelining and like multiple exporters versus one exporter? If that's part of the exporter work, then I expect people to argue. Okay, good. But I expect there to be a good, awesome debate there. Yeah. And I think that needs to be called out as an item for someone to push on.
Yeah, so I'll list that multiple pipeline. Okay, I have a specific topic about this here, so I'll cover that later. Any other questions here? If not, then let's give 20 minutes to Josh. So I originally planned to put 20 minutes in last meeting, but we screwed that up. So Josh, sorry, go ahead.
Well, I hope that it doesn't take me that long, and I don't know that I have enough to say for that long time, but there's definitely a debate happening, and I'll try and run people through it. And hopefully that can help us decide how much priority to give it. Let me see, I'll share for a second just to show you a little bit. If you can unshare.
Okay.
Okay. All right, you can see now I posted an issue a week ago after merging an OTEP, which had been open for a long time since March, but this is building on a PR that had been open since, I'm going to say September, October. So this PR had been through a lot of debate, and then we decided that there was so much debate, we couldn't just have a PR, we had to have an OTEP. So the author UK went back to the drawing board and came back with the OTEP, which I merged last week. If you read through this document and the debate that was there, this is primarily being contributed to by the industry here. So Datadog, Dynatrace, New Relic are the primary contributors to this OTEP. And there are some sort of, I call them experts, people who are known in the world for publishing papers about histograms and telemetry industry people who have been added to this thread. At the end of the thread, there was a lot of consensus on this particular proposal. It's an exponential histogram. Sometimes people call that a logarithmic histogram. It's basically the simplest of the kind of parameterized histograms. These are compressible because all the buckets are explained by like one growth rate. So you don't have to list every bucket. You just list your growth rate, and then every bucket index, you can just do some math to figure out where its boundaries are. So that's the basic idea. It's so simple that kind of doesn't require much explanation. So where we ran into trouble, and it's like, this is a long thread, I don't expect anyone to read it, but so the author of Open Histogram came into the room. That's Theo Schlossnagel. The other author of the Zirconis histogram or the open histogram. It's been renamed from the Circonus histogram. Is Heinrich Hartmann. He's been involved in our meetings a bit. He's someone who is interested in open telemetry. He's working at a customer of Lightsteps. I just disclaimer. So there's a connection between me and Heinrich for that reason. But Heinrich was coming in kind of as a neutral party, saying, I don't care what we do, but we want histograms for our users. So Heinrich's surprisingly neutral, given that he's one of the authors of Open Histogram. The biggest claim that the author of Open Histogram came into this room saying is that if you have parameterization and it allows you to have arbitrary boundaries, we are going to end up in a world where histograms get converted from one format to another as they transfer from one protocol to another. And if the boundaries are belong to different, essentially exponential families or different parameterization schemes, you end up with an error being introduced every time you convert these. So the big choice that we're making here, and that the first sort of line in the sand that was drawn by these histogram people, was we should have a non-lossy way to manage histograms, so that ideally all of our data will go into one histogram scheme, and then we don't have to convert between, let's say, binary and decimal. So the first kind of rule that was put out is that we should be able to have a histogram that everyone agrees to use. And this may be actually too much to ask for, because if we decide to go with a base 10 scheme, then all of our buckets are going to be aligned with base 10 powers, essentially. And this is good as long as everyone agrees to it. But as soon as you have someone else who says, I want a base 2 histogram, it means all my histogram buckets are on power of 2 boundaries. And now, if I have to change from one to another, they just don't line up. There's always going to be a little bit of error introduced in order to convert a base 10 histogram boundaries into base 2 and so on. So this debate essentially has come down to let's have a choice here. If we all kind of agree that we don't want 2 histograms, we all kind of agree that we only want to implement one data format, but choosing a histogram means choosing a winner, unfortunately. And Open Histogram is trying to say, I would like to donate this. It's good for the community, but not everyone likes it. And then I would say it turns out that the research and the development that went into this OTEP 149 is actually really compelling. So in the course of discovery here, what we learned about is essentially a new system, which is called UDD Sketch. It's one of the variations on DD Sketch that was published from academic sources in the last few years. And it basically modified DD Sketch with a very simple idea that is very powerful. It says that if you choose a scheme for your histogram and you choose a parameterization that has what we call perfect subsetting, it means that you can have a coarse resolution and a fine resolution histogram. And as long as those boundaries are subsets of each other, the coarse resolution will fall, the fine grain resolution will perfectly subset into a coarse resolution. And then you can downgrade your histograms from fine resolution to low resolution and not introduce errors, so that you can compare 2 low histogram, like you can compare a high resolution histogram with a low resolution histogram, or you can merge them together and get results that have the resolution that you wanted without introducing additional errors. So this idea of perfect subsetting was brought into the conversation, and you can do perfect subsetting for a binary scheme, and you can do perfect subsetting for a base 10 scheme. Now, Open Histogram doesn't actually do this, but it's a fairly trivial extension. So I wrote it up. This is in my ticket here. This is the referendum on histogram formats. So this is sort of a quick summary of the OTEP 149. It says, let's assume that we're using power of 2s as the growth ratio, and they're going to be fractional powers of 2. So it's like, I'm going to say 2 to that 1/2, or 2 to the 1/4, or 2 to the 1/8. That's my growth factor. 2 to the 1/16, to like whatever you choose, it's going to be a number that's slightly larger than 1, and that's your growth rate ratio. So I chose, and then the format of that. Let's see. I didn't write down the equation here, but the format of this proposal in OTEP 149 is that your boundaries are located at 2 to the 2 to the x, or whatever x is, or k, where that's a scale factor. So, and we've inverted it so that larger scales give you higher resolution here. So this is an example of what you would get in this binary scheme. You choose a scale of, let's say 2, it gives you 27 buckets across the range of 1 to 100. If you chose a scale of 3, you get 54, and 4, you get 107. You're doubling every time. And we can always collapse these down, and they have perfect boundaries, so they perfectly subset. So this is actually very close to what we understand Google is using, according to some internal discussions, or Josh Montana has said that. But this is basically the UDD sketch scheme. It is base 2. It means that if you have floating point numbers in IEEE 754 format, you can just do bit manipulations to shift and mask to get the boundary positions for any given floating point number. So there's definitely some, like, assuming you have floating point hardware, this is a really compelling answer. Okay, but why are people talking about open histogram? It's sort of the same idea. You have, and I pulled up their paper. I think they had a great diagram. This is the idea is in open histogram is essentially called log linear. You have 2 parameters. One is the logarithmic scale, and one is a linear scale. So you do logarithmic for your exponents, basically, and then you do linear within each exponent. So in a decimal scheme, I call them decades. Every power of 10 is 1 decade. And in an open histogram format, you do 90 per decade. In the diagram here, it's 4 per decade. So you can imagine having 90 divisions between 1 and 10, 90 divisions between 10 and 100, 90 divisions between 100 and 1,000. And the power of this technique is that all of your divisions land on integers. And that helps if you don't have floating point hardware. It also helps because it maps into these human round numbers. Every open histogram boundary is a power of 10, or a fraction, an integer fraction between 2 powers of 10. And so the reason why 90 is so important is that you have to be a factor of 9 in order to end up with integer divisions between your decades. So open histogram, the number 90 is very important. And that's this line here. You get boundaries at 1, 1.1, 1.2. You get 90 of them up to 10. And then from 10 to 100, you get 1, you get 10, 11, 12, 13. You get all the integers between 10 and 100. That's 90. To do perfect subsetting with open histogram, I basically made this up because I think it's a good idea. And I think the thing that people don't like about open histogram is that it's too high resolution. But if we just take the same perfect subsetting idea from OTEP 149, apply it to open histogram, this is what you get. It makes some good sense. So if I have only 18 divisions per 100 per decade, I end up with these fairly nice round numbers as well, 1, 1.5, 2, up to 10. Those are nice because they actually align with Prometheus boundaries. The default boundaries in Prometheus happen to fall into this category. So that you have 36 divisions between 1 and 100. You have 18 per decade. This is a proposal that, to me, it fits with Prometheus really well. It fits with human intuition really well, but it requires this decimal approach, which is going to be pervasive. And anytime you convert back into another format, you're going to have precision issues, and you're going to introduce errors. So that's the end of my dialogue here. These are both good options. One is friendly towards computers. One is friendly towards humans. I don't believe that there's a great acceleration we get by choosing anything, because we have to build new code from scratch to make this go through the collector. There's going to be a lot of conversions from legacy formats that have to be built. And I think that no matter what we do, it's not going to be a fast move. There's something appealing about choosing open histogram, but it's also pretty contentious. Every single vendor sent somebody into that room and voted against it. So it's not clear why we would actually choose open histogram, given that the vendors seem to strongly believe in the base 2 approach. Now, as soon as I tweeted about this last week, the author of HDR histogram also stood up and said, what about HDR histogram? It's got 10 years of experience, it's widely spread, but it is a more complicated protocol. And the more complicated our protocol, the more work we have in front of us. So there are 2 or 3 options of just styles of protocol, and that doesn't talk about what libraries we're going to use, and that doesn't actually talk about exactly what encoding we're going to use. There's still sparse versus dense encodings and so on. But the biggest choice seems to be choosing base 10 versus base 2 as the kind of foundation, and then we can actually have multiple protocols that convert perfectly between each other if desired. And I don't really know what's best. I was hoping to get lots of input. There is a lot of input, and I haven't even read it all.
Sorry,
So
Josh.
starting about here, 3 days ago, I have not read this whole thread, and I apologize for that, but here we are. I hope I've given you enough background to jump into this thread. Everyone commenting here is pretty much an important person. Gil Tene is the author of HDR Histogram. I haven't figured out who Gar Taylor is yet, but I'm sure. Charles Masson is DD Sketch. UK is New Relic. We've got HDR Histogram. We've got UK wrote an essay here. UK has been the greatest contributor just trying to push this forward. He's dealt with lots of punches. I've asked him to start over again more than once. So he's been doing a lot of work. I don't know what to do. They're all good choices. Would anyone like to speak?
Yeah, so I have a question, Josh. From OTLP perspective, or even like the OpenTelemetry client libraries, do you think we should put a bias, like we pick one, or we should have the flexibility? We allow people to choose, and we offer both or 3 options to them.
What I want is for people to have a choice of library. We should take any library, but the protocol, if we support more than one protocol, like a base 2 and a base 10 protocol, then we get into this world where we have to translate them in and out of each representation, and you have a lossy translation between base 10 and base 2.
I understand.
I'd be interested in having essentially any library, the most popular library, but it has to kind of fit with the scheme in the protocol. So that's why people caution us against having more than one protocol,
So
or more than one sort of scheme.
So how do you think
Say
about
again?
Like if in OTLP we support base 2 and base 10, and we tell people if you have the base 2 input and you also output base 2, and you can have a fine granularity thing, and we'll do the perfect conversion. If you convert from base 2 input to base 10 output, then we'll do some crazy interpolation, and you should expect there's data loss. And this is the best thing we can do in theory. And I've seen that in other metric systems in Microsoft. Like we tell people, if you use this, the input output, we give you the very precise thing. Otherwise, we'll give you the wild guess, like by interpolating data, and you should expect there's error.
Yeah, Lightstep has a piece of code that I wrote to convert from the explicit boundaries of OTLP v07 into circle histogram, because we use it internally. It's a good representation, but there is loss introduced and approximation introduced. And when you're dealing with those explicit boundaries from Prometheus, I'm not sure it matters, but if those are the default boundaries for Prometheus, they do map exactly into open histogram. It's just that the default 12 buckets of a Prometheus histogram become 320 open histogram buckets, which is where I get the idea that's a little bit too high resolution.
Yeah. So I guess probably OpenTelemetry wouldn't want to put a strong preference on one of them.
Well, the only problem concern of mine is that as soon as we have 2, we have to implement twice as much machinery inside the collector, and every vendor is going to be faced with, what if I receive the wrong, and like I have to do conversion. So we can definitely choose to have 2 protocols. Like I think like you could say, let's follow OTEP 149 and introduce a simple base 2 exponential. People like that. And then let's also just slap in a placeholder for open histogram and a placeholder for HDR histogram. And if you get those are 3 formats now, and we can always convert between them. But
I understand.
It's just a lot of code to write and maintain, and I'm worried about it.
Yeah, it's more like the OpenTelemetry, like how OpenTelemetry position itself. Similar like when people work on the W3C trace context protocol. initially they were thinking we want to support all the existing protocols, and later they went to another extreme and say we want to support only one. And in the end, they land in like we have the one, like the trace ID, span ID thing. And we also have the trace state, which gives people a room if they want to interrupt with some legacy existing tracing protocol like B3, they can put that in the trace state. So I think if some project try to target a large scope or large like areas, it normally end up with a compromise. So my suggestion probably like this decision is, to me, it's not like a pure technical decision. It's more like how we position this project.
Yeah.
Yeah. So probably.
So it sounds like you would favor accepting all the protocols and publishing essentially a translation routine that will be standard, and suggesting that the collector could have these conversions built in. So there'd be like a base 2 to base 10 histogram processor, and there would be a base 10 to base 2 histogram processor, and be a HDR histogram to base 2 histogram. It's like HDR histogram is already base 2, but it's got different resolutions across its range. So you to convert it into a sort of simple histogram, you might actually lose resolution, but you can do that. And then to convert from open histogram into base 2, you've got some approximations going on, and the same in the opposite direction. Yeah. It sounds like a huge commitment of resources that we don't really have to maintain and develop this pipeline for the collector.
Yeah.
On the other hand, it sort of is the most accommodating for client libraries. It says the SDKs have the choice to choose the most developed, best choice histogram library, whatever that may be, because we have all support. The problem is that then you end up with a vendor or a customer running a big deployment that's got some Python and got some Java and it's got some Go, and you've got 3 different histograms because 3 SDKs chose 3 different libraries, and now some of them are base 10 and some of them are base 2. And the question is how good are your numbers at that point? And maybe I've been so close to this for a while. I start to question some things. Like a lot of the histogram experts in the room care so much about relative error. So 3%, 4%, like what is your bound on your relative error? And I don't actually have a lot of feeling that people care about relative errors. Like coarsely speaking, I want to see my histogram data, and I've never asked what's the relative error in this data. So if you introduce a 1% error by converting between open histogram and binary, then that seems okay. The problem is like the experts will tell you, yeah, but theoretically that's just a 1% every time you convert it. So like there's like anytime you merge it later again, they compound, I guess. And I'm not sure like that's the type of like fear and uncertainty that comes from those experts, is that like you do things that are not perfect and then it could be arbitrarily bad and it's like panicky, and I'm not sure I feel that way. So Riley, sounds like you'd support all the formats with some conversion routines. Anyone else?
Yeah, and I'm very biased because I work for Microsoft. I've been in this big company for 10 years. I always see like multiple folks debating their big orgs like Windows Office. They're very successful product, but they have very different business priorities. So normally like Microsoft will end up with very complex solution that can support anything, but we're not super good at one particular problem. So that's a big company thing.
From the user perspective, I believe it would be very, very desirable to have just like one format, because as a user, I would hate like having like 100 microservices and 70 of them is using like one bucketing strategy and 30 of them are using like another one. You will not be able to aggregate those. I believe that is basically the biggest advantages, for example, like open histogram, that it makes your histograms aggregatable, which is like a impossible thing other than like if you don't have like buckets that are aligning.
So adding to this, there's one more non-technical consideration, and we're being recorded, so I'll be very careful. Prometheus has opinions, and I think we have to match opinions with Prometheus. And the opinions from Prometheus are also not technical, it turns out. And there are lawyers involved at companies, and I shouldn't say more. There's something going on besides technical debate here, and I'm trying not to say exactly what I know, but there's some choices that Prometheus will not make, and it is being guided by some vendors, as far as I can tell. And this to me suggests that the work in OTEP 149 is our best choice, because Bjorn Robinstein from Prometheus liked it and started to implement it. So there's a preference coming out of Prometheus that might just steer us towards a single base 2 exponential family of histogram boundaries. And I think we can make that decision. And it's going to mean disappointing open histogram. And I think probably what matters most is that we just get this done and get some kind of histogram out. It also feels like a tough decision.
I want to call out one important thing. Perfect should not be the enemy of good here. Users don't have such a histogram today. And I think there is no such thing as a perfect histogram. And we could spend all our time debating what that is. I think understanding what we think is good and pushing from our standpoint an industry standard makes sense. Everyone wants to be the industry standard. And the real question is, adoption will be the key to any histogram kind of picking up. In my mind, the question is open histogram adopted widely and used by vendors and open source solutions today? I think the answer is no. I think we are still in that space where we can make a decision here. We can make the best decision possible. And if we're wrong, what's going to happen is users are going to demand the other format. Then we'll be a 2-format like system. But today, we don't know what adoption is going to look like. And so us picking as a community what we think is going to be the best thing for users is absolutely the right thing to do. And it's not going to be perfect. It's not going to solve everyone's needs and be super happy. But as long as we pick something good and we get it implemented quickly and we drive this thing and get vendors to adopt it, I think it's going to take off. That's my opinion. So if we think it's, everyone froze, so I think my internet's dead.
I hear you.
Okay.
Mm-hmm.
Cool. So you can still hear
So
me.
then,
All right. As long as we pick a good thing, I think, and drive it quickly and do the right thing for users, I think we're likely to have a really compelling use case that pushes the industry. And I think we're at that stage. Everybody wants to get their thing adopted.
Yeah, and it seems to me like the base 2 sounds like the winner for now. And I think as long as we have some room in the protocol, so later we discovered that we need to add another one, it's not going to blow things away. As long as we have the room, I think we should start from base 2 and implement that across all the SDKs and the collector. With one additional thing, we want to leave the room, so later if we want to support both, we can do that without having to break existing stuff.
yeah, we talked about this a couple months ago, the idea that we would introduce new histogram types rather than trying to overload and introduce one-ofs within the existing types. So currently we have explicit boundary histograms. It's called histogram. Maybe we think about renaming it explicit histogram and then have an exponential histogram with base 2, and then you could have a decimal histogram with base 10 later on. I don't know. Or you could have an HDR histogram. The idea that we rejected was that you'd have a sort of histogram type that was general purpose, and then you'd have a subtype, like a buckets type that would be a one-of. There was a little bit of objection to that a few months ago, so that you could have an explicit one-of bucket, and you could have an exponential one-of bucket, you could have an HDR histogram one-of bucket, and an open histogram one-of bucket. It seemed to be just excessive one-ofs, and the preference that we were talking through then was having a particular data type per histogram class. And that does leave us room to add more types, as Riley is asking. Sounds like if this group were forced to choose, we would choose OTEP 149, and we would encourage going forward. Now, the thing that the 149 proposal means is that we are going to lean then on the vendors particularly New Relic, Dynatrace, and Datadog, who all proposed this and promoted this to supply us with implementations that meet our guidelines, whatever they are. And I think there's still quite a lot of flexibility. Like, do you want to have automatically configured histograms that like just sort of vary their size based on the data range? Do you want to have fixed precision? Do you want to have fixed size? Those are two choices, for example. And I think we should try to say as little as possible. And earlier, I filed an issue saying any histogram implementation is acceptable. But I don't know how to say what we exactly want, because I think people don't want to set their boundaries. We've run out of 20 minutes. I don't know what else I can say, but I'd like to hear the group close this out so we can move on to Riley's list.
Okay.
I'm going to go update that thread after I read everybody's, and I'm going to say more or less what I just said, is that we're still leaning towards OTEP 149. We're still leaning towards base 2, and we are expecting the New Relic, Dynatraces, and Datadogs of the world to provide implementations that produce this protocol relatively quickly.
And I put the links.
I'm also willing to post a converter routine between histogram formats. That's a general purpose thing that we've been using, and it deals with zeros, and it's a little tricky to get right.
Yeah, so for folks who want to follow up more, these are the links I just captured from Josh's presentation. Okay, so for the next one, it's a very simple thing. Just mentioned this PR has been a little bit stuck. I believe I solved many blocking comments. So please take a look. And while you're reviewing the PR, I want you to focus on which part you think is crazy or not going to work. And I want to take a step back, and we can remove that section, just mark it as a TBD for now, so we can make progress instead of trying to make this PR a perfect answer for everything. I want to scope down. As long as we can make progress, we have some skeleton, and we solve one problem by noticing it introduced other 2 open questions. I think it's totally fine. We can leave the open question as a TBD and hammer that out in subsequent PR. So I have a scoping question. This is specifically related to the multiple exporter and the multiple pipeline and sampling. So I prepared something for discussion here. If you can see my screen, on the right side, I'm trying to illustrate the extreme case where you have all type of combinations of the exporter here. So this is one single process, this big box, and you have multiple meter providers, they have multiple meters, and they have instruments. And the only one thing you want to remember here on the left side is we have synchronous instruments and asynchronous instruments. So the asynchronous one are not sending data unless someone asks for it. And on the right side, I have 4 combinations. So you have the push exporter. You have the push exporter, but you want to push the data on a different frequency versus the sampling frequency. So here is the sampling. I'll give you one example. You want to measure the soil temperature, but you're running on a big farm, so you don't want to export the data every 1 minute. Otherwise, you would like run out of cache. So what you want to do is you want to measure the soil temperature and humidity every 15 seconds, but you only export the data every 1 hour or a day. So I'm drawing this circle here, indicating that this can run on its own schedule. And you can already see the problem. You might have a situation where you want to measure the blood pressure from a patient every 0.1 second, because blood pressure drops to 0, then patient will die, right? But the body temperature is not likely to change every second. So you probably measure the body temperature every 15 seconds. So in this way, you can already see different instrument might run on its own cycle, and they could be totally different from the exporting cycle. And this has been an ask from folks in Dynatrace. They opened some issue last year about the SDK spec. Here are other scenarios. You have the pool exporter, and when you pool, we're going to collect all the existing data, and meanwhile, we'll call all the callback functions to get the asynchronous instrumentation. And another scenario is you want to pull, but your pull frequency might be different from the collection frequency. Like you collect the soil temperature, but you only pull the data when a drone is flying by the sensor, and then you report the data. So these are the case, and I think ultimately we probably will have to support all of them. But for now, I want us to focus on only being able to support push and pull multiple exporters in the same process on the same meter provider. Whether the instrument can sample at a different rate, this can be added later. And here goes why. Because today, if you're saying, I want to push, then I'm going to call the callback function from async instruments. Or I'm receiving a premises scraper call, I want to pull the data, then I'm going to call the callback. It's not much different from, hey, you have some timer, and based on the timer, you call the callback and push the data to the in-memory state, and later you can decouple that. So I believe this can be added much later. And just to summarize, so my proposal is for the SDK spec, for now, let's focus on supporting multiple exporters, mix and match, like push and pull. But we ignore the sampling thing on the here. And we're basically saying we don't allow instruments to be sampled at a different rate than the exporting cycle. And later we can add that. And I think even after we ship the stable release, we can solve that problem. So I'm going to update the issue, explaining why that's the case and how I believe we can solve that. Just want to see if people think this is a good decision, or you think we should solve this problem right now, or you think this is something we shouldn't even try to solve after stable release. It's just something else people can do their own thing, so we don't have to cover that in the spec.
Question, Riley. When you say multiple exporters, are they, let's say push exporter, are they at potentially different collection frequency?
Yes.
Okay. So if that was the case, in your second example where you have like the sample rate at a different rate than the push, rate, I mean, if you made them the same, would that not simplify it? I mean, it may be just, we already said, I think exporter has the freedom to push whenever they want. So, but from our pipeline perspective, the exporter is at one collection frequency and the exporter may choose to not send it on the wire.
Mm-hmm.
Okay.
Yeah. So here my proposal
Can
is.
I ask a few implementation questions here? So
yeah.
Who decides on the start-stop timestamps for collection? Just to make sure I understand. So in a pull-based exporter,
mm-hmm.
right? When you get a pull, that's when you decide on your stop time for like the cumulative or delta distribution that you're looking at, right?
Yes. Yeah.
And for push, there's something else that decides when to do it. That runs.
The way I think push and pull, they're actually the same. The only difference is push exporter is triggered by a timer or something else, like the memory pressure or something. The pull exporter is triggered by some external call, like the scraper call. But they're both reacting to some signal. So they sit there, do nothing until someone, either a timer or memory pressure or application exit signal or a scraper, ask them, hey, go and fetch the data. At that moment, they would wake up and see what's my last time, and they will use that as a start time, and they will ask what's my current time, and so that starts off.
I'm more worried about synchronous instruments here, and my next question is also related. Of in-memory state, do you see in-memory state getting duplicated for every exporter then?
Currently, no. I discussed with Bogdan. I can give an update. That's my next topic. So I think there's a way that we can avoid having multiple in-memory state.
Yeah. So effectively, like just from an implementation standpoint, right? There's with an aggregator. You're keeping track of your internal aggregation and like your actual measurements, and you're putting them into something. And then at some point you get a call that says, okay, produce a metric data point, right? That has like the timestamp of when you produce that metric data point. And the question I have is, should both exporters see the same metric data point? Or is it okay for them to see different metric data points? And more importantly, when does that aggregator reset its state if you're doing a delta? Right? If you're doing cumulative, it kind of doesn't matter because you should be able to just always pull and everything's gravy. But it still does because there's implementation details that are dirty. And for delta, it's absolutely impossible. We need to know when to clear state for delta. And consistently do that. And it's still not clear to me with what you're saying here and what you're explaining, how I do that effectively.
Okay, I'll briefly explain that, and later we have a topic to cover that. So my original thinking.
Could I describe how I did this in the Hotel Go prototype, just as a explanation? So as you were saying, there's always a signal that causes something to happen, and in a poll, it's coming from externally, and push, it's a timer. But I had 3 components essentially in the pipeline. It was called accumulator, processor, and exporter. The accumulator is the one that's responsible for that synchronous switchover between there was a delta before and now I've snapshot and I've given you that delta and I started at the moment again. So that accumulator is responsible for telling you a delta. So it's start time and end time. And then some signal caused it to do the computation, whether that was from a controller essentially, whether it was push or pull, some signal came in. And then one set of deltas for a time slice gets sent to the processor, which then can decide whether it wants to do delta to cumulative. And the processor has the timestamps for that delta, and so that it can do the delta to cumulative and compute the correct timestamps. The only part of my prototype that didn't have was like a variable thing for multiple exporters, but you could accomplish that, I think what Victor was saying, by just essentially having exporters skip an interval if they don't want to export it, so that you still have the highest frequency like trigger going through the accumulator and saying output a delta, output a delta, output a delta, and then the exporters can decide to skip them. And there's still this piece of shared state that's between the accumulator and the exporter, which is where the current value of the metric is. And if you want to just not copy that, it means that your scraper is going to block your accumulator. So you have to be careful. If you aren't copying that state, you might block yourself with a scraper.
Yeah, I agree. There's a copy stage here. What's interesting though, how are you handling the case where you want to remember a measurement that happened in a previous collection interval that's cumulative, but doesn't show up in your current delta?
There's a current state is being held in the processor. And if you need to do delta to cumulative, or if you just need memory for any reason, which is Prometheus needs it anyway, like old gauge values. There's no delta being computed. I just need to remember my old gauge value. So you keep a current state in the processor if you must. And there will be stateful pipelines that do that.
Which processor?
This is not
so
old
the SDK
terminology.
defines a measurement processor and a metrics processor. The processor you're talking about, as far as I understand, is something totally different.
Well, it is closer to the metrics processor, and I think of my accumulator as being closer to the measurement processor, but I didn't. So this is, but this component that I'm calling processor is really just responsible for any state that happens to be in the pipeline, because it's receiving updates and it's being read by exporters. There's this like kind of special kind of stateless case where you don't need any state in that processor. And in that case, you just pass through and remember nothing. And all the outputs of the accumulator go straight into the exporter. That's the case where you're exporting deltas.
Yeah, so for the pipeline, I think there's a way that we can share the state and all the exporters will share the state, and the state will be able to report whether it's cumulative or delta based on the highest frequency among all the exporters. So imagine you have exporter
based on a preference of the exporters.
Yeah.
So there's this extra hook in my prototype that says before I know how to set up my processor, I have to ask whether the output's going to be delta or cumulative, and then the exporter gets to say what it wants, and then that sets up.
Yeah. So
it unfortunately means that the processor depends on the exporter to know what type of processing to do.
So I'll explain the story where I talked with Bogdan. So imagine you have an exporter that send the data every 1 minute. So you send the data 1 minute, and then you reset the delta. You start from 0, or you keep the cumulative, whatever you do. And then at some point, for example, you just export the data. You're waiting for the next minute to come, and all of a sudden, a pool exporter reported, "Hey, I got to respond because there's a premises scraper." So what you have to do is to ask the aggregator, whatever we call that, to give the data. And that aggregator will give the data to all the exporters. While the push exporter, every 1 minute, the exporter is going to scream and say, "I'm not ready. I'm only expecting the data to come after 1 minute. So what I'm going to do is to take the current delta, put it somewhere on hold, and I'll wait for the next data to be reported. And if all the data reported meet the 1 minute bar, then the exporter is going to export the data. And the exporter doesn't have to do its own aggregation. The exporter can simply call the aggregator, "Give me the data, I'm not ready, so just keep it somewhere. And later you have additional data, merge that. And now I'm ready, so give the final result to me." So that part, I think definitely we need some spec. So I'll probably talk with you, Josh, tomorrow, and then we can figure out how we can make a PR. But that should be a separate PR than the view PR.
So Riley,
So I
question.
understand.
So in that last scenario, you're just, if I understand this correctly, you're just saying that the exporter needs now to have the ability to merge metrics.
No, it's not. The exporter
Call it processor.
To ask for it. The exporter can tell, "You give me some data, but I'm not ready. So next time when you give me the data, I want you to merge and give me the final result."
So who's doing the merge?
Wait for the next PR.
Okay.
It's just to give you a heads up. We're not, the pipeline problem is currently a to-do item, so we won't be able to solve that. Just heads up, this is the thinking. If you have a different thinking, you should bring the topic here. But if you wait for the answer, then you should wait on the PR for the answer.
So
the system that you described is definitely more complicated than any I had ever wanted to implement, and I was hoping we would never go there. But I believe you could take multiple of the processor components I've described with different state requirements and like wire them together so that you've got one processor that receives that first push, and then the exporters that have like limited push frequency will get pushed again but not trigger, and like it's just going to be an arrangement of state and exports that skip triggers essentially.
Yeah, so I'll talk with some experts offline, because this part I figure if we have a big meeting, it could last forever. So come up with some initial proposal, and I'll send a separate PR on this.
The point I'm leaning on there is that there was this stage where the accumulator dropped some data into a processor, and it has to build a merge right there in order to compute cumulative state. So the same machinery should be able to use to compute a sum of deltas that's like an intermediate result.
100%.
I can see opportunity to use the same code in multiple ways to accomplish all these configurations.
Yeah,
you don't necessarily have to do that, because you could just keep the storage around for cumulative state as well if it's more efficient to do so than convert to a delta and then take the delta and convert it to cumulative.
That's another fine point, is that before people do these complicated arrangement of deltas, they'll switch to cumulative and then you don't need it.
Yeah, but I like the idea you're proposing, Josh. The thing that I'm still trying to noodle around is this notion of the collection interval and the exporter. If we detangle the two, it becomes a little more clear, because basically you can have a slot for all your metrics, that you just have something that samples your metrics and shoves them into that slot. When you get a call from Prometheus, you won't sample the metrics at the time of the call. You just sample like the current value in this like double buffering scenario of I flip my metrics over every once in a while, right?
That's how the Go prototype does it today.
That's how you do it today? Okay, that it wasn't clear to me that that's how you did the other half of it. Okay, so that makes sense. That's what I was thinking of doing in the Java prototype as well. But I do think we should probably do some more focused discussion, maybe in chat, just design ideas, flesh this out, because this is getting this right across languages is going to be interesting. And I don't want to limit language implementations based on one language's strengths and another language's weaknesses. You know what I mean? So, okay.
So I'll ask this question. I mean, it seems like we're going to these schemes to potentially avoid, memory usage. So if that is the case, and maybe that's not the case, but if that's the case, do we have a sense of, how much memory we're really talking about? Because from, at least in my implementation, for most of the aggregators, the memory usage, it's really not the actual accumulation of the value. It really is just the expansions of the label set combinations. Right now, I haven't looked at Histogram, which probably has a higher memory, needs. But for the simple ones, like just either a delta or a cumulative or whatever those are, the memory doesn't seem to be an issue. And if that is the case, then would we not be simpler if we just had a in-memory block for each exporter frequency? Anyway, so that's a thought.
Yeah, so we're exploring different possible ways of doing that. I think as the next step, I'll reach out to some of you offline and try to capture different ideas, and then I'll compose the ideas, put some document there so we can discuss and comment. Okay, moving to my last topic. So I talked with Bogdan yesterday about the delta versus cumulative. This is a question I received when I sent the view PR, because people ask, hey, when I define something, whether it's a view or I use the exporter, do I have the flexibility to specify I want to export the data as cumulative or delta for sums or like histograms? So here's my thinking. I'll explain that to you. I think if you export data to some backend that only support cumulative, then asking the user to do some configuration is like a no-brainer thing. So we shouldn't. Like if we send data to Prometheus and Prometheus only supports cumulative, we should convert everything to cumulative if we can, without asking the user to specify anything. If we send data as delta, like to a delta only backend, we should also do the same thing without asking the user. The interesting problem happened when we export that to some backend that can support both. In this way, originally I was thinking I'll just be lazy. So if we got an absolute value from the async instrument, I'll export that as a cumulative. If I got that from a synchronous counter something, I'll report as delta. But Bogdan changed my mind. So this is my original proposal. But Bogdan mentioned we probably need to give the user some flexibility. And it seems that cannot be part of the processor or the view configuration. It should be exporter configuration. And here goes why. So Bogdan believed if you're running behind the load balancer, like the collector is running behind the load balancer, you have multiple things sending that. The collector will have no good idea how to do the conversion because the start time and all the other mess. So it will be, the earlier you can do that in the SDK, you will have much more information. So you can give the more accurate value. So the assertion here is, if you have to do the delta cumulative conversion due to whatever reason, then you should do that in the SDK or as early as possible. So that part got me convinced. Then I started to think in the SDK, in the OTLP case or whatever exporter that you can support both, you should give the user a way to do cumulative or delta. What I'm struggling and I want to get feedback here is, do you think that's like one single option? Say I want to export everything here as cumulative or delta, or you want to have fine granularity. Say I want to export A as cumulative but B as delta. By default, I would avoid the complexity, but I want to see if there's a valid business consideration. So Josh, go ahead.
Yeah, this has been discussed in the past, and I have a feeling. But the reason why this is so hard to discuss in the open community is that Prometheus only accepts cumulative and nobody cares to talk about deltas really. I'm really looking forward to a time in the future when OTLP is enough established and our SDKs are enough established that we can advertise, hey, database vendors or timescale DB or Victoria Metrics, would you like to talk about accepting data in deltas? Because it has a lot of performance benefits for the sender and different performance characteristics for the collection infrastructure. I don't think that people want to always convert cumulatives to deltas. And what we see instead is that people are converting cumulatives to gauges in these other systems, so that there's probably never a reason to do cumulative to delta inside of an SDK. There is the reason that you just gave to compute deltas to cumulatives in the SDK, but it means putting this memory burden inside the SDK. So there's definitely an appealing option outside in the future when the vendors or when databases actually support it in the open source world. Lightstep supports both right now, but it doesn't matter to anybody because so many people care about Prometheus that they're not going to think about deltas and saving memory. But I did create an option for the OTel Go exporter. It's an exporter configuration, as you said, to choose whether you want cumulative delta output. And the one that makes sense for me is a stateless option. So you say, I don't want to do delta to cumulative because it just causes a buildup of memory. And so you can imagine then for all the synchronous instruments, well, counters and histograms, do you want to actually pay the cost of memory or do you want to just flush out those deltas? What I found is that people get really hung up on up-down counter here because they traditionally want to see them as gauges. If you start pushing your delta to cumulative out of process for up-down counters, you run into this like reset problem that rates can be, that you can't compute the total anymore, and it becomes a potentially useless metric to a lot of people. There's so people are interested in having cumulative up-down counters. It seems quite strongly, but then I think it does make sense for performance reasons just to give the deltas for counters and histograms. So I've imagined a sort of a pure stateless option, which is where there's no memory and everything is either cumulative or delta according to the instrument. But I think that users want an almost stateless option, which is everything except up-down counters are stateless. In any case, to answer your question, Riley, it's an exporter configuration.
Do statsd counters not like are they just dead? Like nobody at all uses them anymore?
Well, people use them, but they don't often. It's unclear whether many people use them as up-down counters because of this loss of total value. People tend to use gauges in statsd instead if they care about the total value.
The only use case I'm talking about is where you run a local collector and you try to get the metrics out of process as quickly as possible to be resilient to failure in your main process. And so that your metrics pipeline and your main process have different failure, domains. That's what I'm talking about specifically as that use case, which is the statsd, shove this thing out as quickly as I can. And I would call that thing an up-down counter. If that's not a valid use case we care about at all, then I totally agree with you around up-down counter. And I would say that people who are used to Prometheus and see up-down counter as this weird thing. Sure, I buy it. But I don't want to throw, I don't know. I thought that was the primary reason you use statsd, but I could be wrong.
I think I'm trying to draw a distinction between counter and up-down counter. Counter, that's the bread and butter of statsd, is that you're outputting these deltas and you can convert them into rates. You don't ever care about the total, and the rates are always going to be correct. It's this case where you drop some deltas for an up-down counter that the total value is now completely unknown. And as long as the user only cares to see the rate of their up-down counter, that's fine. But I've seen a very strong signal that people don't want to see those values be broken down into deltas. They want to represent them as totals. It's just that they want the API to let them increment and decrement it, so that you end up asking for synchronous up-down counter, keep the memory there because it's pretty important. And for every other instrument, you don't need memory, including asynchronous up-down counters. Those are always correct. So you don't, it's not, they're never put in the delta format.
Okay.
Eventually, because of Prometheus, Hotel needs to support both, right?
The protocol has both. We're waiting for a wide user base or a number of vendors and an open source ecosystem to just support deltas. And what's the motivation for me? It's that we can do high cardinality at some point with deltas. We lost Josh. Riley, how do you feel about this?
Yeah, currently I would prefer to have one option on the exporter, and we don't do that on the view, because I think, like I explained the reason. I think putting the option on the view seems like a dumb approach.
Yeah, there's just so few people that want to accept a mixture of delta and cumulative right now that it almost doesn't seem too important to me. But I could see, like, you know, I want to it seems to me a decision about where you put your memory. So yeah, it's not really a, you know, so until there's a widespread reason to do deltas, I don't think this conversation is very important. And we'd always said the default will be cumulative just to avoid having this conversation.
Yeah. Yeah, sounds good to me. Okay, thanks, Sarah. We're running over time. Have a good one. Bye.
Thanks, Riley.